welcome to our mathematics lesson. I am Skhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. We are continuing with our lesson on measurement patterns. Do you remember what we learned last week? You have to remember what we learned last week because this lesson is mainly based on what we learned last week. You have to remember those things, okay? Right, but anyway, I'm going to remind you, but I'm not going to go into detail. I'll just give you the formula and then you can use the formula, okay? Right, what are we doing today? Grade 10s, we are looking at the volume and surface area and the effect of K. The effect of vector K. We're going to look at that. Let's be ready for the lesson. Right, so what are the objectives or the objective? Right, we're going to determine the effect that multiplying any of the dimensions of the prism by a factor of K will have on the area and volume of the prism. What do I mean by that? Let's say if we multiply the length by 2, what will happen to the volume? Will it also be multiplied by 2? What if we multiply length and breadth by 2? What will happen to the volume? Will it also be multiplied by a factor of 2? What if we multiply all the 3 dimensions, length, breadth, and height by 2? What will happen to the volume? Is it going to be multiplied by 2? That's what we need to find out today. That's the main purpose of today's lesson, okay? Right. Vector K can be 2, can be 3, can be 4, can be any value, right? Now, so our lesson is going to be like investigative, We need to observe something, do the calculations, and then we observe, and then come to the conclusion, okay? That's how the lesson is going to be structured. We have done area and volume, like I said. We need to remember these two for this lesson to be nice, so that you can enjoy it and understand. Given the following closed rectangular prism, that's our baseline activity, calculate the surface area of the prism, and then calculate the volume of the prism. So 1, you can choose any formula that we used last week. Remember, we say there's 2 times length times breadth, and then there's 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. That's one formula that you can use. Check your notes, you must be having it. And then the other one, we say that you can say 2 times the area of the bases, or 2 times the area of the base plus perimeter of the base times height of the prism. Do you remember those ones? Okay, let's try to do the baseline, and then I'm going to give you 5 minutes for question 1, and then let's say 5 minutes for both questions, question 1 and question 2. You can have 3 minutes for question 1 and then 2 minutes for question 2, and then when I come back, we'll do both questions once. So you have a total of 5 minutes. Let's try. Right, welcome back, greetings. Let's do this together. So the first one, we're going to use the formula which says surface area is equal to 2 times length plus, 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. Okay, remember we discussed this in our previous lesson last week. So we substitute our length and breadth and height, and then we get that our surface area is, what is it? It is, oh, we don't need all these steps. So the surface area there is 700 square centimeters. You can put this thing in the calculator as it is, and then you get your 700 square centimeters. SA means surface area there, stands for surface area. Okay, please mark your work. You have to remember this formula. We're going to use it today. So if you don't have it now, please write it down. Write it. Okay. All right. Let's go to the next one. Next one. Another way of doing this, you can use this formula which says that the area of 2 times area of base, if we take these ones as our bases, these two, so it will be 2 times area of this base which I have shaded, which is 2 times 10 times 5, because the area of this base will be 10 times 5. Then plus perimeter of the base, perimeter, the distance around the shape, which will be 2 times 10 plus 5. Okay, 2 times 10 plus 5, that's the perimeter, times height of the prism. Height of the prism, remember, it is the distance between the two bases. So this will be the height of the prism. So you can use this formula. Please, if you don't have this formula, please write it down. We're going to use it somewhere in the lesson, right? So area of the base is 10 times 5, and then you multiply that by 2. That will be the area of the two bases. And then the area of the lateral faces is this one, which will be the perimeter of the base. Perimeter of the base times height of the prism. This gives you the perimeter of the base. 2 times 10 plus 5. 10, then 10 here, 5 here. That's why I say 2 times 10 plus 5. That's the perimeter of the base times height of the prism. It will give us the area of the lateral faces. Okay, right, and then substitute into the formula, and then we put in the calculator, we get the same area, which is 700 square centimeters. I want to give you 1 minute, and then if maybe you did not write the previous formula, let me write it for you so that you can copy this after 1 minute. For 1 minute. Okay, so the surface area, 2 times, you can say length times breadth, plus 2 times length times height, plus 2 times breadth times height. Each must appear twice. Length, length, breadth, breadth, height, height. It's fine. So you can copy this in 1 minute, then we continue. We go to the volume, then we continue with our lesson. Let's try. Welcome back. Let's continue. We want to find the volume. I said you must use the 5 minutes for both the surface area and volume. Volume is very easy. Just length times breadth times height, you get your volume. So it's just 10 times 5 times 20. Length times breadth times height times length, just the same thing. Remember, multiplication is commutative. So it is 1000 cubic centimeters. Okay, right, we've managed to do our baseline activity, and also this has assisted us to remember the surface area of prisms and also the volume of prism. We're going to use the rectangular prism for this lesson. Remember what we want to check. We want to see the effect of K, factor K. Right. Right, given the two rectangular prism, we have rectangular prism A and rectangular prism B. I want you to look at the dimensions of these two prisms. Look at the length, breadth, and then height. What can you say? The dimensions of rectangular prism A are multiplied by a factor of what to form the dimensions of rectangular prism B? Are we multiplying the dimensions of A by 2? Are we multiplying by 3? Are we multiplying by 4? I want you to do that in 1 minute. The dimensions of rectangular prism A are multiplied by a factor of to form dimensions of rectangular prism B. So what do we multiply the dimensions of rectangular prism A with to get the dimensions of rectangular prism B? Let's try to do that. 1 minute. Well done, grade 10. So if we check here, we multiply the dimensions of rectangular B by 2 to get the dimensions of what? Of rectangular B. We multiply the dimensions of rectangular A by 2 to get the dimensions of rectangular B. So now, all the three dimensions, we multiply the length by 2, the breadth by 2, and the height by 2. Now, what effect will this have on the surface area? Our 2 is our K value that we're talking about, the effect of K. So our K here is 2. We want to see the effect of this 2, which is the K, on the surface area. That's what we want to find out. So let's do this, grade 10s. I want you to find the area, surface area of rectangular prism A, and then surface area of rectangular prism B, and then we're going to compare them after that. You may use this formula. I'm going to use this formula. But if you are comfortable with the other one, 2 times length times breadth plus 2 times length times height plus 2 times breadth times height, you can use that one. But when we're doing corrections, I'm going to use this one. I'll use the other one for the other example. Let's find the surface area of A and surface area of B. Just that for 5 minutes. Right, welcome back, grade 10. I want us to do this. I'm going to show you the answers now. If you got them wrong, that's correct. Okay. Right. So the first one, the surface area of A, 2 times the area of the base. This is our base here. 2 times the area of the base plus perimeter of the base times height of the prism. Okay. This will give us 52 square centimeters. Please correct that if it is wrong, but if it is correct, well done. And then we go to rectangular prism B. We use the same formula, 2 times the area of the base. This is the base, 4 times 6. So we multiply by 2 because there are 2 bases there. And then times plus perimeter of the base times height of the prism. And then we get 208 square centimeters. Right, remember what we did. We multiply the dimensions of rectangular prism A by 2 to get the dimensions of rectangular prism B. So now, is the surface area of rectangular prism B be 2 times the surface area of rectangular prism A? Let's find out. So if we say 52 times 2, do we get 208? No. 52 times 2, we get 104. We must multiply 52 by what? Just say 208 divided by 52. What do you get? 208 divided by 52. What do you get? You get 4, which is 2 squared. We get 4, which is 2 squared. So we multiply the surface area of rectangular prism A by 2 squared to get the surface area of rectangular prism B. But what did we multiply the dimensions of A with? We multiply the dimensions of A by 2 to get the dimensions of B. And then the surface area of B becomes surface area of A times 2 squared. Can you come up with a conclusion from that? Remember, I said our 2 is K. So what conclusion can you come up with from that? Now, from this now, we can see that if length, breadth, and height, if all the 3 dimensions are multiplied by a factor of K, in this case our K was 2, then the surface area is increased by a factor of K squared. Okay? Please write this one down, this point. If the length, breadth, and height are multiplied by a factor of K, then the surface area is increased by a factor of K squared. That's what we have just observed. Let's write that one down, 1 minute. Right, welcome back, grade 10. Remember our WhatsApp line 063-508-1301. Let's engage each other during the lesson. Right, now I want us to use what we've learned. Given the rectangular prism, this rectangular prism, calculate the surface area of the rectangular prism, that's A, and then calculate the surface area of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 3. If the length is multiplied by a factor of 3, the breadth is multiplied by a factor of 3, the height is multiplied by a factor of 3, what will be the surface area of that prism, the new prism? I don't want you to use the dimensions. I want you to use the factor k. What did we say from the previous slide? What did we say? We say that if length, breadth, and height are multiplied by a factor of k, then the surface area is increased by a factor of k squared. That's what I want you to use there for question B. So you're going to do question A and B, and then I'm going to just go through C and D. Yours is A and B for 5 minutes, then after that we discuss. Let's try. Right, welcome back, returns. Let's do this together. Now the surface area is going to be, we're going to use this formula. Even if you use the other one, it's fine. So we're going to get the same area, which is 280 square centimeters. Right, so B says, calculate the surface area of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 3. We don't need to do a lot of things here. So we just multiply the area of this rectangular prism by what? By 3 squared. We just multiply the area of this rectangular prism by 3 squared. Then we get the area of what? Of the new rectangular prism. Okay? And then see, I just want to prove this. Okay? That we're going to get the same area. Right? So we have the surface area of that we got 2,520 square centimeters. Now let's do this. Let's multiply this one by 3, we're getting 15. Multiply this one by 6, we're getting 18. And multiply this one by, I said multiply 5 by 3, we get 15. Multiply 6 by 3, we get 18. Multiply 10 by 3, we get 30. So we've multiplied all the dimensions by a factor of 3. Now let's find the surface area of this new rectangular prism. Are we going to get this? Yes, let's see. So we put in the formula and then we're getting the same value. Do you see that? So if you have an area of a rectangular prism and then you're told that every dimension, all the 3 dimensions are increased, let's say by a factor of 3, then the surface area will change, will be multiplied by a factor of 3 squared. If all the dimensions are increased by a factor of 5, are multiplied by a factor of 5, then the surface area is going to be multiplied by a factor of 5 squared. Okay, right. So that's what I wanted us to discover in this lesson. Right, we'll talk about the other dimensions if 2 dimensions are multiplied by a factor of k, if 1 dimension is multiplied by a factor of k. But now let's look at volume. Oh, we haven't done D. If the length, breadth, and height are multiplied by a factor of 3, the surface area is therefore increased by a factor of 3 squared. Okay, right. What about volume? Let's look at volume. Again, it's going to be sort of investigated. We're using the same rectangular prisms. We have rectangular prism A, rectangular prism B. We say that length is multiplied by 2 to give us 8. Breadth is multiplied by 2 to give us 4. Height is multiplied by 2 to give us 6. So all the dimensions are multiplied by a factor of 2, just like when we're talking about what? The surface area. Now, let's calculate the volume of rectangular prism A and rectangular prism B, and then after that we compare. Are the volumes of these two? Should we multiply the volume of rectangular prism A by what? By 2 to get the volume of rectangular prism B? Or should we multiply by 2 squared? Or should we multiply by 2 cubed? Let's find out. Let's start by finding the volume of these two. Remember, volume is just length times breadth times height. It's easy. Let me give you 3 minutes for volume for both A and B. Let's try that. Right, welcome back, Cretans. Let's see what we have for volume of rectangular prism A. Length and breadth times height, we have 24 cubic centimeters. And then for rectangular prism B, we have 192 cubic centimeters. So what do we multiply 24 with to get 192? Or what do we do? Maybe say 192 divided by 24, what do you get? Remember, we change the dimensions by 2. We multiplied every dimension by 2. Okay? So if you say 24 times 8, isn't it? Okay? If you say 192 divided by 24, you get 8. So it means we have to multiply 24 by 2 cubed to get the volume of the new prism, or prism B. Okay, so what conclusion can we make from this? If we multiply all the 3 dimensions by a factor of k, then the volume should be multiplied by a factor of what? By a factor of k cubed. Okay, k cubed. Let's conclude. So we're saying if length, breadth, and height are multiplied by a factor of k, volume is increased by a factor of k cubed. Please write it down. Let me give you 1 minute for that. 1 minute. Right, welcome back. I hope you managed to write your notes. Now let's do an activity, a short one. We'll do like the previous one. You can do A and B, right? So what we do, calculate the volume of this rectangular prism, and then B says, calculate the volume of the rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 4. So our volume is going to be multiplied by a factor of what? Okay, so you do A and B, and then I will do C and D. Let me give you 3 minutes. 3 minutes, let's do A and B. Welcome back, greetings. Let's check what we were supposed to do. So calculate the volume of rectangular prism, length times breadth times height. We're getting a volume of 300 cubic centimeters. Right. And then do we need to multiply every dimension by 4? No, we now know that if all the dimensions are multiplied by a factor of 4, to find the volume, we just say the volume of this times 4 cubed. Remember, so to calculate the volume of a rectangular prism that is formed after each dimension of the given rectangular prism is multiplied by a factor of 4, we just say our volume, which is 300 for this one, times 4 cubed. Okay, see, I will show you that these dimensions will give us this, because see, 5 times 4 we got 20, 6 times 4 we got 24, 10 times 4 we got 40. Now these three, 40, 20, 24, will they give us this? Yes, they will give us that, definitely. So we say 40 times 20 times 24, which is 19,200 cubic centimeters. Okay, right. So that's what we have learned in this part of the lesson. If length, breadth, and height are multiplied by a factor of 4, and then volume is increased by a factor of 4 cubed. Generally, we'll say if length, breadth, and height are multiplied by a factor of k, then volume is increased by a factor of k cubed. Remember, we're looking at the effect of k. Okay, right. Now I want us to discuss this. I won't have time. Oh, I gave you notes to write that one, but these ones, I'm just going to tell you, and then I'll give you time to write your notes. Okay, first one. We're not going to investigate this one. I'll just tell you what it means. If length and breadth, or length and height, or breadth and height, it means that if you just change the 2 dimensions, not all of them, not the 3 of them, if you may change length and breadth, length and height, or breadth and height, if you change 2 dimensions, if you multiply them by a factor of k, can volume also be multiplied by a factor of k cubed? No, it can't be, because you're just changing 2. So if you multiply 2 dimensions by a factor of k, then volume is increased by a factor of k squared. Please take note of that. Okay, and then the other one. Now, let me give you time to write notes before I move on. Right, 1 minute for this, then we move on to the next one. 1 minute. Right, welcome back, greetings. Now, if length or breadth, not n, or height. Now, if you change 1, if length or breadth or height is multiplied by a factor of k, then the volume is increased by a factor of k. Now, check. If all the 3 dimensions are multiplied by a factor of k, the volume is going to be multiplied by a factor of k cubed. If only 2 dimensions are multiplied by a factor of k, then the volume is going to be multiplied by a factor of k squared. And then if one dimension is multiplied by a factor of k, then the volume also is multiplied by a factor of k. Please take note of that. Let me give you 1 minute to write this, and then we come back and I think we'll be going through our homework. Just copy this for one minute. Right, welcome back, grade 10s. Now it's time for us to write the homework. I will give you time. We have time, so we can copy our homework nicely. This is our homework. Please copy it, and then after that you can do it and then submit. Right, we can have even 5 minutes. Let's have 5 minutes for this. We can draw our diagram and write our questions. 5 minutes. Right, welcome back. Grade 10, I really hope you had enough time to copy the homework. We had all the time to do that. Now, let's summarize our lesson. What did we say? If the length, breadth, and height are multiplied by a factor of k, surface area is increased by a factor of k squared. That's what we have observed. And then if the length and breadth and height are multiplied by a factor of k, then volume is increased by a factor of k cubed. And then we say that if the length and breadth, or length and height, or breadth and height, meaning that two dimensions, are multiplied by a factor of k, then volume is increased by a factor of k squared. And then if the length or breadth or height, it means if you change one dimension, if one dimension is multiplied by a factor of k, then volume is increased by a factor of k. Okay, right, that's what we learned in this lesson. Thank you very much, grade 10s. We're meeting here every Thursday at 9 a.m. In our next lesson, we're going to look at the surface area and volume of other 3D objects. Remember, we talked about prism in the previous lessons. So we're going to be looking at the surface area of spheres, cones, pyramids, and all those other 3D objects. Let's meet next week on Thursday at 9 a.m. Thank you very much. Goodbye.